Hello friends, in this video we'll be discussing quadrilaterals under the head of geometry. So let's start. Now at the very outset, if I make a statement like a quadrilateral, all quadrilaterals are parallelograms, or if I make a statement like all parallelograms are quadrilaterals, and this may look to be slightly out of place, just think on this. Second, can I say everything starts with a parallelogram if I exclude a trapezium, which is also a four-sided figure? So in the very beginning, we need to understand that a quadrilateral is a figure which is formed out of four sides. I mean, if there are four sides enclosing an area, that enclosed area, because of this, the figure will be known as a quadrilateral, right? Because it has four sides. Second, we were talking about, can I say that every quadrilateral, I mean, which are the quadrilaterals that we can talk about? Every quadrilateral is a parallelogram. Now, what are different type of quadrilaterals that we can talk about? We can talk about a square, we can talk about a rhombus, we can talk about a rectangle, and the fourth excluding parallelogram. Let's say, so what are all quadrilaterals that you can talk about? So let's say one, we can talk about parallelograms, another we can talk about rectangles, then squares, then rhombus, then trapezium. So how many categories have we talked about? We have talked about 5 different types of quadrilaterals. Now, which are these 5 types? I'll just repeat for your convenience. First, we talked about a parallelogram, then rectangle, then square, then rhombus, then a trapezium. There could be a 6th variety which does not fall under these 5. So these are the 6 different type of quadrilaterals that can be formed. So if I exclude the trapezium and the 6th variety that we talked about, any other form of a quadrilateral which is not among the 5 that we talked about, the 6th we talked about is any other form of a quadrilateral which does not belong to these 5. These 5 we have already talked about. So from these 5, if I remove a trapezium also, so I have removed 2 varieties of quadrilaterals. So we have remaining 4 varieties. These 4 varieties are parallelogram, square, rectangle, and rhombus. So we are going to start this discussion with these 4 varieties, and among these 4 varieties I am choosing a parallelogram and I am saying every quadrilateral. So we are talking about the 3 quadrilateral excluding the 2. So every quadrilateral, for example, can I say a rhombus is a parallelogram, a rectangle is a parallelogram, a square is a parallelogram, and definitely a parallelogram is a parallelogram only, is a parallelogram. Let's see how. So in this video, our focus would be only on a parallelogram, and in the subsequent videos, we'll be talking about other varieties of quadrilaterals as well. Right? Okay. Now, I have assumed this to be a parallelogram. Now, when I say that I have assumed this to be a parallelogram, that means the piece of information that needs to be given to take this figure as a parallelogram or to assume this figure as a parallelogram is AD is parallel to BC, and not only parallel, both of them are equal also, and at the same time AB needs to be equal to DC and at the same time parallel. If these 4 different pieces of information are given to each other such that there is an area enclosed because of these 4 lines, then the figure that is formed is known as a parallelogram. I hope I have made myself clear. Now, the next thing that I have done here is I have divided this into 2 triangles broadly. So can I say one triangle is DAB? So I have drawn a straight line DEB. Now what is E? If I say that this is the diagonal of a parallelogram, one of the diagonals is AC and the other diagonal is BD, I'll call this as a diagonal only when I'm able to prove that AEC, and at the same time DEB. Both of them need to be straight lines, as we have been doing in other videos as well. So how do I prove this? But even before that, let us just use the property of parallel lines. So if I say that this is a straight line, I have assumed this to be a straight line. In that case, if this is angle A, this will be angle A. If this is angle B, this will be angle B, and thereafter the remaining angles will also be equal. For example, the remaining angle here, if this is D, this also becomes D. If this is C, this also becomes C. This can also be proved. Okay. Now once we have assumed this, we can say that the sum of, so if I take this triangle, I know this angle is D, this angle is C, so I can use remote exterior angle theorem, and I can say D plus C is equal to this remote exterior angle. The same thing I can do with respect to this triangle, the triangle BAE, and I can say A plus B is this angle. Then these are vertically opposite angles, and so are these. These are vertically opposite angles. Now I can use the property of rectangles as, we can use the property of triangles here as discussed earlier. Triangles are very important and we talked about 4 things: similarity, congruency, perpendicularity, and parallelism. So parallel lines. So these 4 things are very, very important when it comes to geometry. So the moment we are able to make 4 different triangles out of this parallelogram, I can use the sum of all interior angles of a triangle, and I can say that A plus B plus C plus D is equal to 180 degrees. Now the point here is I need to prove that the line AEC is a straight line, and which is not only a straight line but it acts as a diagonal as well. So in that case, A plus B plus C plus D should be equal to 180 degrees, which it is. So can I say AEC is a straight line, and the same thing I can say for DEB. That means these are not only straight lines but these are diagonals as well. So AC is one of the diagonals of this parallelogram, at the same time DB is another diagonal of a parallelogram. Now from here itself I can say that angle A, so in the parallelogram the opposite vertex angles are equal. If this angle is B plus C, so is this angle. If this angle is A plus D, so is this angle. So I can say angle A is equal to angle C and angle D is equal to angle B. These are all characteristic properties of a parallelogram. Now when we were able to make these minute angles, we are doing the micro analysis here. When we are able to do this, so can we say that angle A plus angle D? Now when I say angle A plus angle D, we are talking about alternate angles. Alternate is one after the other. So either I take A along with B, or I take A along with D, or I take D along with C, or I take C along with B. All of these are, or I take B along with A. These are all alternate angles. And can I say the measure of all these, when I say the measure of the sum of all these should be equal to 180 degrees? Yes, I can. The next point which is important here is, now I know that, can I say these 2 triangles are similar? Because if you recall, we talked about congruency starts from similarity. That means the stepping stone for congruency is similarity. So can we say that these 2 triangles are similar? Yes, these 2 angles itself. So there are at least 2 angles which are equal, which will say that these 2 triangles are similar, and so we can say for these 2 triangles. So we have a pair of triangles which are not only similar but they'll be congruent. And why do I say that they'll be congruent? Because I can use A angle side angle, right? So we are talking about angle A, side AB and angle B. Then we are talking about angle C, side CD, and then we are talking about angle D. So can I say triangle BAE is congruent with triangle DCE? Congruent with, or congruent to. At the same time, can I say that the triangle ADE is congruent to triangle CBE? Yes. The moment we are able to establish the congruency between these 2 pairs, now once I know that these 2 triangles are congruent, So can I say, now this is angle B and this is angle B. So the sides opposite to this. So once I know that this triangle is congruent with this triangle, so then I can use anything. I can use SAS, I can use whatever. I can use ASA, which I've already used. I can use triple S, I can use double AS, I can use RHS. Now RHS here is out of place, but the remaining I can always use. So once I know that these two triangles are congruent, the ratio of their sides should also be equal to a 1. Now when I'm talking about the ratio of their sides, the only thing that I need to remember here is, if this is angle B and this is angle B, it is only the opposite sides. So these two sides would be equal. And when I talk about the third side, so I'm basically talking about angle A. Angle A and angle A here. So even these two sides would be equal. Right. So which means what? Which says that E acts as, so the point E bisects these two points, these two areas. So can I say AE is equal to EC? I can. And at the same time, can I say DE is equal to EB? Yes. That means the diagonals of a parallelogram they get bisected. And if the diagonals of a parallelogram gets bisected, and I know that, if I know that every quadrilateral that we talked about, whether it is a rectangle or it is a square, right, or it is a rhombus or a parallelogram, is a parallelogram only. So when the diagonals, so the broader side is a parallelogram and everything fits into it. Everything is the three more things that we talked about: rectangle, square and a rhombus. So if the diagonals of a parallelogram will get bisected, the diagonals of others should also get bisected. Right? We'll talk about this in detail the time when we talk about the other three quadrilaterals, and then we'll establish a relationship. Okay. So now once we are able to establish this, this says what? This means that, so we said what? AE is equal to EC, and at the same time DE is equal to EB. Okay. So now we know that these are congruent triangles, and we know that the congruent triangles have equal areas. So let's say that the area here is A1 and A1. Right? Now, can we say that AE is nothing but, whether it is AE or it is DE or it is EC or it is BE, these are nothing but medians? Medians of the triangle concerned. So when I take the triangle ADB, I'm saying that AE is the median for the triangle ADB. And we know that median, we have had a discussion, we have had a video on medians as well, which says that the median divides the area of a triangle in two equal parts. So once I know that this area is A1 and this acts as a median, in that case this area will also be A1. And once I know that this acts as a median, BE acts as a median for the triangle ABC, in that case this area will also be A1. So you will see that the four triangles which have been formed here will have equal areas, but equal areas is because of what? It is just because of we got the triangles as congruent, but all the four triangles are not congruent to each other. Mind it, we have already proved pair of triangles only being congruent, which means what? So which we have been discussing in the past also, but I am just revising it once again because there are certain things which you may encounter many a time. And what are the things that you would encounter? Equal areas may, it means equal areas. If there are two triangles having equal areas, that does not mean that both the triangles would be congruent. They may or may not be congruent. But if I am talking about two congruent triangles, in that case, they will definitely have equal areas. Okay, so when I say that all these four triangles are having equal areas, that means the four triangles may or may not be congruent, right? And when we check this, we find that it is only these pair. I mean, if I talk about these two pairs, I mean, this pair is a congruent pair and this pair is a congruent pair. And both the pairs are different from each other. Okay. Now, what is the next point here? The next point here is, because of this, you will be able to say that the length of the diagonals, because of which, just because of the medians discussions only, you'll be able to establish that the length of the diagonal AC is not equal to the length of the diagonal DB. This is not the only way. There are other ways also in which you can establish this, but with the help of this, you can establish this. The next point here is, can I drop a perpendicular from here to the opposite side? Yes, I can. So what is the area for this triangle? I mean, the height for the triangle BDC is BF. The height for the triangle BDC is BF. And the same thing I can say for the triangle ADC also, the height is BF only. The height for the triangle ACB also is BF. And the height for the triangle CAB also is BF. Right? So, and now once you know, you already have the area. So what is the area for this triangle? Twice of A1. What is the area for this triangle? Twice of A1. What is the area for this triangle? Twice of A1. Right? And what is the fourth one? Where is the fourth one which is left? What is the area of this triangle? That is also twice of A1. So can I say that the area of the triangle ADC is the same as the area of the triangle BDC? Yes. Can I say area of the triangle DBA is the same as the area of the triangle CAB? CAB, yes. At the same time, we can say that the area of all these four triangles are equal, and they are equal to A1. Last but not the least, there are many other things that you can talk about here, but last but not the least here is, now we know the median theorem, and the specific name that is given to the median theorem is Apollonius theorem. So in one of my videos wherein we talked about the median theorem, we talked about the Apollonius theorem also, but we did not name it. So what is Apollonius theorem? Apollonius theorem is nothing but you are trying to relate the median, the length of the median, the length of the square of the medians with the length of the square of the three sides of a triangle, is nothing but what the Apollonius theorem is, which we have already established in the video wherein we talked about the medians of a triangle. So using whatever we discussed there, using the same thing here, I can say, if I talk about the triangle ADB, AD square, so we are using the median theorem, which is nothing but Apollonius theorem. AD square plus AB square is equal to twice of the median length, which is AE. Now AE square plus BE square or DE square is what the Apollonius theorem is. I'll just write it down for your convenience. If I talk about the triangle ADB, so I am talking about the triangle ADB, Apollonius theorem or the median theorem, the length of the median theorem, says AD square plus BA square will be twice of the length of the square of the length of the median. Incidentally, the median here is AE square plus either BE square or DE square. BE square or DE square. So using now this Apollonius theorem, I am just reframing this. So how do I reframe this? AD square plus BA square is twice of, how much is AE? Now we know that AE is what? AE is half of the line segment AC. The line segment AE is half of the line segment AC. So here we have written it as AC by 2. And similarly, BE is nothing but BE is nothing but half of the line segment BD. And the same thing that I have used for the other triangle. So I have divided this entire parallelogram into two different triangles. One is, we are talking about triangle ADB, and the other triangle that we are talking about here is triangle BDC. So from the triangle BDC, again articulating, we'll be able to say that DC square plus CB square, DC square plus CB square is twice of, this is half of this, which is AC by 2 whole square, plus this or this, which is half of this. Now I add these two. What is the relation that I get now? Let's see that. So we are getting what? We are getting AD square plus DC square plus CB square plus a BA square is how much? So when I add all these, how much should I get? So let's see. So here we are getting 4 times. If I add these two, I am getting, so we are basically getting, this is nothing but AC square plus BD square. Let us say, had this been a square, I mean just to relate with a square. So the length of the diagonal of a square can be found out from this formula, which is just like saying what? Pythagoras theorem. Right? So anyway, so the length of the diagonal of a square is a root 2. Now a root 2 whole square is how much? 2a square. Now 2a square plus 2a square is how much? 4a square. And we know that a root 2 would be only when the length of the side of the squares would be a. So a square plus a square plus a square plus a square makes it 4a square, which means the left hand side value is equal to the right hand side value, which means that the formula is correct not only for quadrilateral, I mean not only for parallelograms, but maybe for other form of quadrilaterals also. And those other forms are either a rectangle or a rhombus, or we talk about rectangle, rhombus, or we talk about a square. The last thing here, now if somebody tells me that this is a quadrilateral and these are the midpoints of a quadrilateral, if you join all the midpoints, what is the resultant figure that you are going to get? So in here we can use something which we have already discussed earlier, which is basic proportionality theorem, or let's say midpoint theorem, which is nothing but an outcome of basic proportionality theorem only, which is, can I join these 2 points? Yes. Now can I say the triangle? Now this vertex angle is the same for this. So once I say this, and so we know what? We know that PA upon PQ is the same as PA upon PQ is the same as PD upon PS, which is the same as DA upon SQ, which is nothing but 1 by 2, which is already given. So this piece of information is already given. You are dividing the sides, you are bisecting the sides. So you are taking the midpoint of the sides, and all the midpoints of a quadrilateral are joined, and you get a resultant figure which is a quadrilateral. Now you need to check which kind of a quadrilateral is this. Incidentally, here you have to prove whether it is a parallelogram or not, because we talked about parallelogram few minutes back. So using Bpt theorem or midpoint theorem, we'll be able to say that this thing happens only when these two lines are parallel. The same thing you can say for this triangle and this triangle, you get the ratio as half. So you would say even this line is parallel to this. Now the same you can say, you can join these two, and you can use the same midpoint theorem or basic proportionality theorem for this triangle and this triangle. So eventually, and then you can talk about this triangle and this triangle. So you land up saying what? You land up doing this. Now once you're able to do this, you get what? You get opposite sides which are parallel to each other. But this happens for all. So I have just given you a food for thought. The only thing that you need to do here is now use Bpt theorem to prove that the figure that you're getting inside is one among the 4 quadrilaterals that we have already talked about. So either it has to be a parallelogram, or it has to be a rectangle, or it has to be a rhombus, or it has to be a square. Right? So I've just given you some food for thought, so that you can practice this and profess this on your own. And by the time we would have talked about other quadrilaterals also, you will get the final answer for this. If you feel that something very, very informative and interesting has been discussed in this video, give us a like for this video. Right? If you have already subscribed to our channel, please click on the bell icon and select all so that you can start receiving updates from us regularly. If you want us to do some specific videos on some specific topics, please put it in the comment section so that we can cater to your request. Thank you so much. Until next we meet, goodbye.